Hello students, I am Ekta. Today we are going to learn the graphical representation of data. In our modern world, data is the heartbeat of decision making. Whether it's your morning weather update, your fitness tracking app, or even the stock market trends that influence your investments. We rely on data to make informed choices. Here's the tricky part, data can sometimes be overwhelming in its raw form. Numbers, spreadsheets, and statistics can feel like an illegible code. That's where the magic of graphs come into play. Graphs are the visual storytellers of the data world. They take those difficult numbers and statistics and transform them into clear pictures that anyone can understand. Today, we will explore how to craft these visual narratives using different forms of graphical representation. Learning outcomes. After the completion of this lesson, you will be able to understand data representation, different type of graphs, construction of the bar graphs, histogram of uniform width and varying width, frequency polygon. Keywords from this lesson are graphs, tables, bar graphs, histogram, frequency polygon, class marks, class intervals, midpoint. The representation of data by tables has already been discussed. Now we will see the representation of data in the graphical form. The graphical representation of data is easier to understand than the actual data. We will study only the following graphical representation in this session: bar graph, histograms of uniform length and varying length, frequency polygons, bar graph. Is also known as a bar chart, is a graphical representation of data using rectangular bars or columns to display the values of different categories. In a bar graph, the length or height of each bar is directly proportional to the value it represents. In earlier classes, we have already studied and constructed bar graphs. Let us see one illustration to recall how a bar graph is drawn and used to interpret the data. The bar graph is drawn between different flavors and the number of students on the x-axis and y-axis with a scale of 1 unit is equal to 2 students respectively. By looking at the graph, we can say that green apple is a favorite candy for 4 students. Caramel is a favorite candy for 10 students. Butterscotch is a favorite candy for 7 students. Banana is a favorite candy for 8 students. That's so easy, right? Now we will construct a bar graph for the following example. Given below are the seats won by different political parties in the polling outcome of state assembly elections. Draw a bar graph to represent the polling results. Which political party won the maximum number of seats? Solution. The given data is represented on a bar graph by taking political party on the x-axis and seats won on the y-axis with a scale of 1 unit is equal to 5 seats on the y-axis. To represent our first head, that is A, political party. We draw a rectangular bar with a width of 1 unit and a height of 15 unit. That is 15 into 5 is equal to 75. Similarly, other heads are represented leaving a gap of 1 unit in between two consecutive bars. The political party A has won the maximum number of seats. Now, children, what if the frequency distribution table is having continuous class interval as shown in the table? Then how the graph is represented? Is it possible to draw a bar graph for the given data? No, right. If there are continuous class intervals, we use a graph form called histogram, which is used for continuous class intervals. Histogram. A histogram is used to represent frequency distribution by means of rectangles or bars whose width represent the class intervals. The areas of rectangles of the histogram are directly proportional to their frequency. Let us see one example of how to draw a histogram of uniform width. The following table gives the lifetime of 400 neon lamps. Represent the given information with the help of a histogram. Solution. First check whether in the table the class interval are continuous and whether the class width is the same or not. If yes, we can draw the histogram for the given table. Or else we need to follow another method. In this case, our answer is yes. Now, take lifetime in hour on the x-axis and the number of lamp on the y-axis. And take scale y-axis 1 unit is equal to 10 lamps and x-axis 1 unit is equal to 100 hours. To represent our first head, that is the bulb that are working for 300 to 400 hours. We draw a rectangular bar with a width of 1 unit and height of 1.4 units, that is 1.4 into 10 is equal to 14 bulbs. Similarly, other heads are represented without any gap between two consecutive bars because the class intervals are continuous. We get the following histogram. Remember, since the first class interval is starting from 300 and not 0, we show it on the graph by marking a kink or a break on the axis. Let us see one more example of a histogram with varying width. 100 surnames were randomly picked up from a local telephone directory, and a frequency distribution of the number of letters in the English alphabet in the surname was found as follows. Solution. In this table, it can be observed that class intervals are continuous but the class width are varying. We already know that the areas of the rectangle are proportional to the frequency in a histogram. So, here the widths are varying and we cannot take those values directly. So, we need to modify in the length of the rectangles so that the areas are proportional to the frequencies. We need to select a class interval with a minimum class width, that is 2. The proportion of the number of surname per 2-letter intervals. So, length of rectangle is equal to frequency into minimum class size or width by class width. Take the number of letters on the x-axis and the proportion of the number of surnames per every 2-letter interval on the y-axis. And take scale of 1 unit is equal to 1 letter for x-axis and 1 unit is equal to 5 surname for the y-axis. To represent our first head, that is the number of letters that are 1 to 4, we draw a rectangular bar. Similarly, other heads are represented without any gap between two consecutive bars because the class intervals are continuous. We get the histogram with varying width. Now, let us study how to draw frequency polygons. Once, let us recall the example 1 of histogram. After drawing the histogram for the data, first mark the midpoint of the tops of the rectangles as B, C, D, E, F, G, H respectively. Here, the first class 300 to 400, we need to find the preceding class, that is 200 to 300. Now, find the midpoint of the imaginary class interval of 200 to 300, name it as A and join it to B. Similarly, let I be the midpoint of the class succeeding the last class of the given data. Therefore, A, B, C, D, E, F, G, H, I is the frequency polygon for the given data. Now, we will draw frequency polygons without using histograms. Frequency polygons can also be drawn independently without drawing histograms. For this, we required midpoint of the class interval used in the data. These midpoint of the class intervals are called class marks. That is, class mark is equal to upper limit plus lower limit by 2. Let us see the example of frequency polygon without constructing a histogram. In a city, the weekly observation made in a study on the cost of living index are given in the following table. Draw a frequency polygon for the above data. Solution. To draw a frequency polygon, we need to find the class mark of the classes given above, that is 140 to 150, 150 to 160 and so on. For class 140 to 150, the upper limit is equal to 150 and lower limit is equal to 140. So, class mark is equal to upper limit plus lower limit by 2 is equal to 150 plus 140 by 2 is equal to 145. Similarly, find the class mark for the other classes. Also calculate the points where frequency is equal to 0. Difference between class mark is equal to 155 minus 145 is equal to 10. First point is equal to 145 minus 10 is equal to 135. Last point is equal to 195 plus 10 is equal to 205. So, the first and last point are 135, 0 and 205, 0. Now, take class marks on x-axis with a scale of 1 unit is equal to 5 rupees and frequencies on y-axis with a scale of 1 unit is equal to 1 week. Then plot the points A 135, 0, B 145, 5, C 155, 10, D 165, 20, E 175, 9, F 185, 6, G 195, 2, H 205, 0 and joining the points by line segments. We get the required frequency polygon A, B, C, D, E, F, G, H as shown in the figure. Students, let us summarize what we have learned. Graphical representation of data provides a visual and easy to understand way of presenting information. Bar graphs, histograms and frequency polygons are commonly used graphical representations. In a bar graph, the length or height of each bar represents the value it represents. Histograms are used for continuous class intervals and the width of the bar represent the class intervals. Frequency polygons can be drawn independently using class marks, which are the midpoints of class intervals. Thanks for watching this video.